So after the last video, I definitely owe you an explanation of why the first prototype of Fume Extractor failed to deliver. An easy answer is that you need to do multimeter stuff and resistor setting before you even try to solder the batteries to your circuits. The fan got overpowered and just burned out. I even heard the smoke. Good thing is that I had another one to redo all my mistakes and show it into this video. I would definitely recommend you to watch this video twice, as I did not pay a lot of attention to the initial guide and failed dramatically. As they would say, measure twice, cut once. Before we proceed to the fixing part, let's have a closer look to the conceptual schema of the build. The setup I'm offering is a little more complicated than the ones presented in other builds, as it utilizes batteries and can work autonomously from the external power source. But still, this is a pretty straightforward build that requires only 5 parts. Fan itself, batteries, which are, I guess, the most expensive part, voltmeter, but this build can do without it, the switch, DC-DC converter, and of course a charging module with protection, in order to be able to charge and discharge our batteries. And also the charging module allow our build to work from the external power source. And as a plus, on top of that, you would need ventilation pipes and some sort of case in order to extract the fume to the outdoors. The overall cost of a build is around $40, considering I've got parts for 2 or 3 builds, as buying some parts by one piece is unreasonable. For example, DC-DC converter goes in a pack of 5 and you can save them for later. Throughout the build, when I was vacuuming everything around, I accidentally vacuumed one of the switches, but I didn't bother because I had 3 additional ones and I just proceeded with the build. So I would definitely recommend to overbuy some stuff in order to do mistakes when you're building yourself. If I were buying this build again, I would definitely buy 3 fans instead of 2, because you don't know whether the second try you do it, it may fail. And also 2 additional batteries will serve you a good job if you have troubles with the first 2. I've had a series of problems throughout the first video, which I categorized into the following points. First of all, the drilling. If you drill a hole, make sure it is slightly bigger than the part you are going to move through it. For example, if it is a switch, use the size 6 of a drill bit or more, as I had to redo the holes several times. Same applies to the holes for wires. The bigger, the better. I really struggled to put wires through something less than size of 3, because some wires are too fluffy and are unable just to proceed through the hole, and sometimes you need to put through one hole the 2 wires, and it's very difficult. And also holes positioning matters too. The hole for battery to the left and battery to the right better both go to the right corner, as it allows the best wires alignment. Be creative and compact. Be ready to struggle. As I struggled with the switch. In order to insert it correctly, you need to play around with cutting square deep for it, otherwise it won't fit to the fan. I did it with a drill, and you can do it with a grinder, or if you have a special solderer for plastics, you can just solder this part, but whatever will do. The second pool of tips is the wiring. Of course, it is important to place the wires that go from the left to the right and from right to the left to be under the DC-DC converter, as otherwise it will look ugly. As you can see on my final build, there is still a red wire going around the DC-DC converter because this was a voltmeter which I failed to install at the beginning, and thus I had to do some overplay. And secondly, cut your wires to match exactly the length between components. As you can see in my first video, I did big loops that look unaesthetically and probably caused some issues in operation. When you solder one wire, you can overheat the insulation of another wire and it could short circuit in some way, I guess. And also the length of a bare end on the cable must be the same size as the platform you're going to solder it to. No longer, no shorter. The isolation must start right where the platform ends. This skill set will be helpful for your more complex build. Use as much as you need, no more, no less. And thirdly, a couple of tips on soldering. Use flux on wires, soldering pen and platforms. If something is not soldering to something, you use not enough flux. After you finish, use isopropanol alcohol to remove excess of flux with toothbrush, because if you don't, some components may rust. And also double wires are a pain to solder to a circuit. On my second attempt I was soldering them one by one, but still it was floppy, and you probably have seen my attempts to solder 2 wires at the same time on the first video. Especially it's a pain in the ass to grab them with pinset in order to hold them while you're soldering and a few seconds after. Another tip on soldering is to adjust the temperature accordingly. I started with 330 degrees Celsius, but it did not go well. So I used 370 and soldering went smooth. But be careful to not overheat the platform, because it may cause the whole part to malfunction. Keep track on stuff, as you may overheat something. And additionally to these tips, there are a couple of more. Less glue, the better. When you add glue, you may overdo it and it will look bad aesthetically. Plus, glue thin lines will be all around causing a trouble. And talking about the glue gun and other parts that have wires all around your table, keep the solder out of those parts. I did overheat the power cable of my glue gun while being in assembly filming Crash. It's better to have a special place where to put your solder away if you're not using it, because it is extremely warm and it can interfere with other parts and cause them to burn. And finally, when I'm finished with the tips, the reason why you all opened this video is how to actually fix the issue with the first build. So the idea is simple. Before soldering power cables of the fan to the circuit, you need to check the voltage of the power output after the DC-DC converter. From stock it goes uncalibrated, so you will need a multimeter, preferably with clips, and a screwdriver to adjust a small screw on the board. Initially it was recommended to do 5 spins, but I ended up doing way more, to reach the 10 volts output. Usually a fan works on 12 volts, but I was afraid to burn it out again, so I did it precautiously on 10 volts, and after you are done with adjustments and you see 10 volts on multimeter consistently, proceed with soldering the fan wires to the board. I would definitely recommend to periodically test if your fan is not defective with external power supply, just in case. All set up and we can do the first test. And yay, it is working! It took me less than an hour from the second try, but take your time. Now it's time to make a case. In my case, a cardboard box from the vacuum cartridges fits well. It is good enough, but a little bit high. Plus, it is uncomfortable to start and stop the ventilator because you need to drag it out in order to do it. I would definitely make a better case in the future. The pipes went in stock in a length of 1.5 meters, thus I joined them together with adhesive tape. I saw some people use filters instead of pipes, but I consider piping a better solution if you have an access to an outside. And finally we have a great solder fume extractor. The process is fun and you feel like you can do stuff, and thus appreciate it more. As for the upgrade, I would buy additional fan grills to protect the blades, as I was greedy enough to not order it with all other parts. You can find all the parts in the description below. These are partnership links directly to the sellers from who I was buying all the parts. It was pretty cheap and they delivered it on time in a good quality, so I would definitely recommend them. Subscribe to not lose this channel, save this video to rewatch while building, and see you on the other side.